Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we will be looking at the Ford hybrid transaxles that have been used by Ford in their hybrid electric vehicles since the 2005 model year. This model that I have right here is actually a 2005 model year ECVT, as Ford calls it, an electronic continuously variable transaxle. This model is developed by Aisin Corporation. It's the Aisin Model HD-10, and Ford used it in their Escape and later on in the Mercury Mariner hybrid, I believe, also. This system uses two electric motors. We have a traction motor that propels the vehicle down the road. We have the smaller motor that acts as the alternator for the vehicle, and the starter motor to start the 2.3 liter 133 horsepower Atkinson cycle engine that came in that Ford Explorer. This traction motor adds another 87.13 horsepower to that 133 horsepower of the internal combustion engine and helps propel the vehicle down the road. The electric motors have instant torque, and so they provide the power for the low speed acceleration, and then the internal combustion engine has the higher end torque, and the combination of these two, the electric motor for low speed operation and the internal combustion engine for higher speed operation, made a really good hybrid electric vehicle back in the 2005 model year. This Escape, I think, was rated around 30 miles to gallon in the city, which was remarkable back then for the time. All right. This two-motor design here is exactly the same, except it's in parallel axes rather than on the same axes as the hybrid electric system used in the Toyota hybrid systems in the Prius and so on. The only difference is, once again, that we have the two motors parallel to each other instead of in line with each other. They're still connected to the power split planetary gear set the same way. The traction motor through its drive gear and the transfer gear here in the middle and this gear below the planetary gear set still connects to the ring gear. The starter generator motor still connects to the sun gear, just like in the Toyota hybrid system. The planet carrier has a shaft that goes all the way out the bell housing, connects to the torque damper that bolts to the flywheel, that bolts to the crankshaft of the internal combustion engine. So this is the same power flow design, but this is actually a little bit more efficient. This seems to be a little bit better design. And an interesting thing about this is that the new 2016 and above Toyota Prius now uses a parallel axis transaxle instead of the motors that were on the same axis. And the reason for that, I believe, is you can get it in a smaller package. Instead of having the two motors in line with each other, you put them parallel to each other. The overall transmission width is reduced. Additionally, I was just at some Chrysler training on their new hybrid and electric vehicles, and the new 2017 Chrysler Pacifica plug-in hybrid minivan will also have a parallel axis hybrid electric continuously variable transmission. They call it a single input electric variable transmission. I don't know if Aisin makes it or who makes it, but I saw a cutaway drawing of it, and it looks exactly like this. Okay, so what parts are involved? How does this thing work? We are going to take a look at that, but I need to show you the different generations of this transaxle before we move on. So this is the first generation, 2005 through 2008 Ford Escape with the 2.5 liter or 2.3 liter engine. The final drive gear ratio on this thing is 3.04 to 1. 76 teeth on the ring gear, 25 teeth on the transfer pinion gear. and that's a pretty decent gear ratio. An interesting thing, if you look at the labels I've stuck on the traction motor, is we have a 10.706 to 1 traction motor to tire, or ring gear here, gear ratio, which means that that traction motor spins 10.7 times for each revolution of the ring gear, half shafts, tire, and wheel assembly. So a typical tire speed at around 75 to 80 miles an hour is 1,000 RPM. So if this is going 1,000 RPM, this is going 10,700 RPM. So it's these were limited to around 13,500 RPM from the research that I've been able to find. At those speeds, the internal combustion engine has to be on to keep the smaller motor from overrunning. Now, this first generation hybrid Escape did not have an electric vehicle mode. In other words, the engine always had to be running, is my understanding, except for an idle stop, I believe. Correct me if I'm wrong there, you guys that know more about it than I do. So let me show you the pieces of this transaxle. We have the final drive assembly with the differential gear set in it. We have the electric motor starter generator that connects to the sun gear of the planetary gear set that's right here. We have the parking gear that your parking pawl would go into right here. If I reach underneath the transaxle and spin the input shaft, that is the planet carrier that's being turned there. If I hold the ring gear still, like if we were in park with the engine running, notice that the generator is turning and the traction motor is going nowhere. This first generation Ford actually had a one-way sprag connected here on the planet carrier, and I can't find any documentation of what that's for, but I believe that it's one of two things. Possibly, one, it allows this starter generator to assist propelling the vehicle down the road without cranking the engine over, because this sprag would stop the engine from cranking, and this electric motor here could actually assist the traction motor in rotating. The other thing is it may assist in starting the engine as the vehicle's moving. I'm not really sure on that. Like I say, I can't find any information on the operation of this transaxle other than what was published in the SAE article by the people that developed it. But they talk more about the control of the transaxle rather than the mechanics of it here. We have a transfer gear. As you can see here, this transfer gear has 3 gears on it. So this upper gear here is what connects to the final drive and drives the vehicle down the road. This gear right here connects to our starter generator motor, and well, actually it connects to the ring gear of the planetary gear set, and then the planet carrier and the starter motor can assist in turning that gear there. And then that bottom gear connects to the traction motor drive gear. So this transfer gear here has three gears on it. Of course, the traction motor has its own drive gear to drive the transfer gear to drive the final drive. So on these different versions of this transaxle, different generations of it, there are different gear ratios possible for these. And the Toyota version of this for the new Prius, and I suspect, although I don't have any proof yet, on that new Chrysler Pacifica, that they'll all have their own unique gear ratio, but they all have the same 3 electric motors, the same transfer gear looking design and final drive. So this is the first generation hybrid transaxle used by Ford, developed by Aisin, used in 2005 through 2008 escapes. All right, here's the second generation transaxle used by the Ford hybrid Escape, 2009 through 2012. So this was also used in the Fusion, and of course the Mercury variations of this also. But if you look at the first generation, developed by Aisin, second generation also developed by Aisin, this is the HD-20, where the first generation was the HD-10. Very same parts. You've got the starter generator motor, you've got a traction motor, but instead of the 87 horsepower, this one's bumped up about 5 or 6 to 93 horsepower. The final drive gear ratio has gone down. It used to be 3.04, now it's 2.538. Other than that, they got rid of the sprag, the one-way clutch that was on the Planet Carrier. And oh, I forgot, on the top of the Planet Carrier here on all of these generations, there's this little gear here. This gear drives the oil pump of the transaxle on this model. So let me zoom in just a little closer here so you can see that. This is the oil pump drive gear right here, and it is connected right to the top of the Planet Carrier. Okay. Other than that, these motors are the same size. This one is bumped up a little bit in power. We have a different gear ratio, so transfer gears on this one are the same gear ratio, but the final drive gear ratio is different. So the transfer gears were the same as far as the drive and driven gears on both electric motors. All right, so this is the second generation. Once again, both of these are Aisin designed and built, used by Ford in their hybrid electric vehicles. All right, now, then for, let's see, this was 2009 through 2012 on the second generation, 2005 through 2008 on the first, and now 2013 through 2016 on the third generation. And this is the totally new, designed in-house by Ford. It's all total unique design for the third generation. So let's take a look at it. So this transaxle, as you can see, looks very similar to the designs of the previous two. For those of you who insist that this is a totally new Ford unique design, take a look. It looks just like the other ones, but it's a really cool design, and I want to take you through the pieces and the operation of this latest transaxle design. Okay, in this design, there are some differences. The final drive gear ratio is different. If you recall, on the first generation back here, we had a 3.04 to 1 final drive gear ratio, and then the second generation was 2.538, and now we're back to a 2.905 transaxle gear ratio. The traction motor has a 10.391 ratio of turns to the rotations of the final drive, where the second generation went clear down to an 8.9, and the first generation was 10.7. So we're back up to almost the 10.7 where we were in the first generation. Both the second and third generation models have an electric vehicle mode where it can drive on electric vehicle power off of the battery until it gets down to a certain point, and then the internal combustion engine turns on. While it's in electric vehicle mode, the starter generator motor will be rotating, and it has a gear ratio of a negative, so it's spinning the opposite direction of the traction motor, 0.995. So in other words, it's almost spinning exactly the same speed, 0.995. The second generation was a negative 1.2, so it was spinning a little faster, which is probably why they didn't have as high of a vehicle speed on the second generation as they do on the third. On the third, I think I read they're going clear up to 85 miles an hour in electric vehicle mode, where on the second they couldn't go that fast, and I think it was because they were going to over rev the starter generator motor assembly. Okay, let's take a look at some of these pieces. We've got the final drive right here, of course. That just lifts out. It's just a traditional open planetary gear set. So we'll set that off to the side here. We have starter generator motor. That's all Ford calls it, is the starter generator. Toyota would call this a motor generator number 1 or MG1. I'm not sure what the Chrysler Pacifica version of this will call it, but this motor just comes right out. It has bearings that support it. This has permanent magnets in it, so you got to be real careful where you lay it, because it wants to stick to everything. And then while we're here, right on the front input side, of course, we've got the sun gear, and that sun gear connects over here to our starter motor alternator. Now they're stuck. All right, we've got our planet carrier right here that is going to connect, as you can see these splines right here, this is going to connect to the damper. It's like a clutch damper. It acts as a breakaway point if something fails between the transmission input and the internal combustion engine. So all your power from the engine comes in here. So that's your engine. And then this ring gear right here through the final drive input gear, through the transfer gear, through the traction motor drive gear, connects to the traction motor. So when this traction motor turns, let me put this back here. There we go. If the traction motor turns, so does the ring gear. They are physically connected together, and that's what I was telling you before was a similar design to the Toyota hybrid system design. All right, so when the traction motor spins, so does the ring gear, so does the final drive gear here. We've just got on the ring gear bearings that hold it in place. On the traction motor side, the motor itself comes off. And then we've got the traction motor drive gear. Oh, I got to get the counter gear out first. So we've got the counter gear and then the traction motor drive gear right here. So here's our empty case. This is our bell housing area. Engine, of course, bolts up right here. This is our right-hand output shaft, and that's it. It's a fairly simple internal component transmission. So, all right, so we've got our traction motor drive gear, 26 teeth on it, drive 93 teeth on the transfer gear. And then, of course, our electric motor sits on top of that. And over here on the other side, we have our final drive input gear that's connected to our ring gear. It has 59 teeth on it, and it drives 83 teeth on the transfer gear. So it fits in there. Then we have our planetary split gear set. We have 86 teeth on the ring gear, 26 on the carriers, and 34 on the sun. So we'll put our planet carrier back in here. By the way, none of these parts are serviceable, except for a few bearings. But nothing on the electric motor side of the transaxle is serviceable. So here's our sun gear and its bearing. Our oil pump drive gear, just like on the other two. Our starter motor, alternator, generator motor. And then our final drive unit. Just like that. Okay, so for mechanical controls of this transaxle, as you can see, there's not a lot of pieces here. We've basically got that 10.3 to 1 ratio of the traction motor turning the final drive here, as you can see. As you can see, we're not connected at all to the generator starter motor. When all of that turns, it turns the ring gear. And if I stop the engine by holding the planet carrier, now you can see that it forces both electric motors to turn. This one would be a generator. This one would be your power driving down the road. So it's a fairly simple design. Once again, used in all three generations of Ford hybrid electric vehicles and plug-in hybrid electric vehicles. The 2016 and above Toyota Prius and the 2017 Chrysler Pacifica minivan all use this same design. I'm sure there's some minor differences. Toyota's oil pump is out here on the end instead of down here, and Chrysler's is somewhere else, but the basic design of having two electric motors, a transfer gear, and a final drive all in one narrow housing is common now to three different vehicle manufacturers. I'm going to have a Chevrolet Volt transaxle video here shortly, and it has two electric motors, but it's a totally different design than this. It's nowhere near this design, so we'll take a look at that later. All right, so once again, three generations: the Aisin HD10, the Aisin HD20, and the new Ford transaxle that they call the HF35, and used all the way up through 2016. What I read for 2017 is that they have made the motors lighter weight. And I suspect there's some other changes to improve efficiency. If you look at each one of these, each one has only lasted for about 4 years. 2005 through 8, 5, 6, 7, 8, that's 4 model years. 9 through 12 was 4. 13 through 16 is 4, so it's time for another design anyway. Okay. That is the control, or I'm sorry, those are the parts in the transaxle, but let's just take a quick look at the transaxle cases, because there's some differences there and differences in power output that we can explain here also. As you can see behind me on the bench there, I have some transmission cases and inverter converters, and so let's take a look at some of these now. All right, I have the first generation inverter converter assembly that bolts on the top of that transaxle on the opposite bench over there, and it's liquid cooled. As you can see, there are some cooling passages. Right here. This inverter converter assembly is, I haven't measured it, I don't know, maybe 18, 20 inches long. And if you look at if you compare it, so here's the first generation inverter converter to the second generation one. The second generation one is much longer. So let me put the two next to each other, as you can see here. So we've got the first generation Ford Escape hybrid inverter converter off that Aisin HD-10 transaxle right here. This is what does this is what drives the electric motors. It has an external DC to DC converter. The second generation one, as you can see, is longer. It's probably 6 to 8 inches longer, and it's longer because on the second generation they installed a boost converter to bump up the voltages while driving the vehicle. So the first generations had a 330 volt battery. The second one went down to 300, I believe, but then they used a boost converter to boost the voltage up, just like the Toyota hybrid systems did. Toyotas had a low voltage or a high voltage system on their first generation, went to a boost inverter and a lower voltage battery on their second one, just like these two. They were both developed by Aisin. Anyway, if you look at these transmission cases over here, let's look at the first generation one. So you can see there are cooling passages. So this entire assembly bolts to the top of that transaxle on the first generation. This entire assembly, this larger one, on the second generation, bolts to the top of the second generation transaxle, and it's much taller. The third generation one over here, the Ford HF35, has an external inverter converter that has the DC converter built into it. So the first and second generations had their own external DC to DC converter. Third generation, it's all in the inverter converter assembly with separate wires to connect the inverter converter to the transaxle underneath the hood. The new Toyota Prius has gone back to the bolt-on to the top of the transaxle inverter converter. So we've got all three generations of transmission cases lined up here. As you can see, they're very similar in design. The first generation has a few unique things, including a hydraulic clutch pack that actually can stop the starter generator motor from spinning. But I have no information on when it would do that and why it would do that. If it stopped that, that would force the engine to start. Maybe that's one way to do it. I'm really not sure. And when I check it hydraulically, there's no fluid passage going to this clutch. So in this model, it's just kind of a dead clutch pack. It was like a leftover design change, I think. But one other thing I want to show you to finish this up is if we look right down the barrels of these transaxles, they are almost dead on as far as the holes that the electric motors go through. As you can see here, this would be the big traction motor. This would be the smaller starter generator assembly, and then your final drive over here. Okay, well, this has been a comparison of all three generations of Ford hybrid transaxles. It's been very interesting to acquire these and explore them since there's no information on them. As I mentioned before, the new Toyota Prius 2016 and above uses this same design, and I was able to find all kinds of good information on how the system operates in that or in their service information. But of course, Maybe they control things differently, but mechanically it's identical, except for the gear ratios. I have a table with gear ratios that shows they're very, very similar. All right, thank you for watching.